couple more minutes, I guess. But I read the wrong clock. Okay. Take this out of the package now. No, there's a little. Two points. So about 2 more minutes because I looked at the wrong clock, which is great. I meant to do that. Not at all. All right, so it's 2 o'clock-ish, give or take 30 seconds. So I'm gonna get started. So today's demo is going to be about cutting metal. And everything except for 1 or 2 of these things is all designed or set up for doing just that. And we've got different tools here. Oh, bench is a little bit wobbly today. I've got grinders, sawzall, different configurations of torch, and in the back I have a chop saw, which at some point I will walk all the way across the shop and show you how that works to a certain extent, because I can't really get a good close-up of it. But I'm going to start where I normally do with this silly thing, because it always ends up living on this table, and I like talking about it, and also I get to light it a little bit. So when you're cutting metal, what you're trying to do is you're either trying to remove some of it, or you're trying to, no, that's pretty much it. You're trying to remove some of it. And by virtue of that, we end up with a cut. That can be a saw cut, it can be a cut with a grinder, a sawzall, flame cut. I don't have in this shop yet a plasma cutter, which is a really handy tool, which actually uses electricity and an arc and air to push away the metal that that you're trying to remove. It's a very rapid way of doing that, and you can use it either manually, meaning by hand, or you can use it using computer numeric control or CNC if you have that set up, which is fairly expensive. With that, couple things. A lot of people, like when I was a kid, as I said, the reason I go back to this guy is this is what we had hanging around. I didn't grow up with a shop like this. This is all stuff I've built in my adult life. This flame is hot enough to melt solder, which has a fairly low, few hundred degrees melting point. It's also good for, if you have a part that needs to be heated gently. So soldering, general heating, which can be used for different things. This guy isn't for cutting. This is for global heating and soldering. And the reason I bring this up is because when people think of torch, or they're like, blowtorch, this isn't what we're talking about. This is a torch, but this is a propane fired torch with a little igniter on it. This does not get metal hot enough to get out of the way. So, as I said, starting there, just because it ends up on my bench because I use it quite frequently for different things, and that's saying that isn't effective, but what I'm trying to distinguish is that there isn't just, it's not a one-size-fits-all world. So what I've got here, I've got a couple pieces of metal, and I'm going to go over a couple of these tools. Some of them I'm going to use, and some of them I'm not really going to. So our destruction friend, the Sawzall. So I've got a metal blade in here right now, which I'll take out. This one's actually been used quite a bit. I've got a brand new one here. And I'll bring this over to the camera real quick. This one right here. You can see this has a lot of teeth, meaning that I'm going to take a real small chip size out of whatever I'm cutting. And the reason I'm bringing that up is because you see instances with Sawzall blades that you have a lot of teeth, you have somewhere in between, and you have very few teeth. Metal blades are traditionally ones with a lot of very small, fine teeth. And the reason for that is we need to basically nick away very slowly at whatever material we are going to be cutting. So Sawzalls are good for rough cutting, demo work, especially in houses and other things. They're not great for accurate cutting of metal. And the reason I bring this guy up here is I can cut this. I can cut, this is about 3/16 thick. Now, let's just do it real quick right here. Move some of this other stuff around. I'm not going to cut through this entirely. I'm going to clamp this to the table so it doesn't take off. But take my Sawzall. And you can see this is moving. I did make a cut in that. I don't want to wreck that whole blade because I don't have a lot of them. So you can see right here, I did cut. I removed metal. There's a fine powder down below. You gotta be careful with that. It's not gonna get in your lungs. Sometimes with that stuff, wearing a mask if you're doing it a lot. Sawzall isn't that, it's a larger particle. But that distance between those two spaces is called the kerf. It's the kerf width, or essentially the size of the cut I get when I am using a blade of X width. So that's the kerf width. I'm going to put that aside. One of the things you have to realize is that's a saw blade. If I have a bandsaw or a portaband or any type of cutting instrument, I'm removing small flecks of metal. Now moving on to something else, this guy. This is a grinder, circular grinder. I believe this one's classified as a 4.5 inch. I always screw that up. So I'm taking it off, has a little nut here. I can put grinding wheels. These are a little bit thinner than I normally use. I grabbed the wrong pack. This is a cutoff wheel. You can see that right there. This guy, same deal, will allow me to cut metal. I'm going to be careful with this because if I accidentally spray my computer, I can damage it. But we're gonna risk it a little bit, so I'll show you what this looks like. So this classification actually isn't the same as this. This is a saw blade. This blade removes bit by bit, tooth by tooth, by moving it back and forth. This is called an abrasive, and that's an entire category. So we have cutoff wheels, we have grinding wheels. These are called a flat disc, sanding discs. Those are all abrasive. They're using friction and the different types of material that these are made out of to remove metal. So what I do with this, and I should be wearing ear protection, I'm only going to do this for a second, so I didn't put my ear pro in. Spins very fast, and by virtue of this material, like I said, I don't want to get that on the computer or on the camera. So I have my original cut right here from the Sawzall. I have my cut from the grinding wheel cutoff wheel right there. And as I said, the difference is this is an abrasive category. And that abrasive is using friction and the material to remove the material, the metal. I'm specifically dealing with steel. The reason I'm going to stick with steel throughout most of this demonstration is it's fairly easy to use. I have a lot of it. And the other reason is that when you get into other materials, there are other things you need to be concerned about, and this is a nice way to discuss that right now. So this is, as I said, 3/16 inches. This is actually the piece you'll see from other videos that I've demoed. It has welds on it and whatnot. Let me get this out of the way. So in that abrasive category, we have the chop saw as well. That chop saw, again, spins very fast, uses a disc, and what we'll do is we use that to, cut larger quantities quicker. It's a portable saw. It's great. And the reason that I want to show you that, and as I said, I can't really bring it closer, and it's just me, and my cameras are wired. So unfortunately, you're gonna have to deal with the distance. I have out here my tape measure. If I was gonna go measure that, it works like any compound miter saw or any saw. I wanna make a mark or have my tape measure aligned with the blade. So if I were to mark this at 20 inches, you can't really see it too well, but mark it at 20 inches, I'm going to cut on this side of this line. I've got my square here, and I'll put that where I made my mark. I put an X on the side of the line that I'm going to cut on. I'm going to consume all that line because it's thick, and then my piece will be exactly the size I want it to be. So I'm not going to cut this one specifically. I just have this here for a demo. I've got a piece already chucked up in there. The difference between fundamentally, the cutoff wheel, put that back out here, the cutoff wheel and the chop saw are fundamentally the same thing. It's just the size and the speed at which they turn to a certain extent. I can't tell you explicitly if this guy and that guy are spinning the exact same size, but you're able to have more of a mechanical advantage with that, and also more precision, because you're able to incrementally set where the blade comes down. So I'm going to walk over there and I'm going to cut that piece. Again, should have ear protection on. I'm only making a quick cut, so. So bring this over here to the camera. It's a pretty even, nice cut. I've got some I've got a little bit of steel from the kerf that stayed with it. I can take care of that pretty easily. As you can see, that's cut a piece of 2x2 box tubing. This is about 3/16. It's about 3/32 of an inch wall thickness. That's this thickness in here. This is a piece of box tubing, 2 inch by 2 inch. Yes, 2 inch by 2 inch. And that wall thickness is about 3/32 of an inch. And that 3/32 of an inch, that's what gives us in this configuration our strength. But it also it increases the rigidity of the piece, but it also allows us to keep a relatively low weight, which is nice. So as you can see, that cuts pretty quick, cuts pretty accurately. Its drawback, so the grinding wheel, the cutoff wheel on the grinder, I'm freehanding that. I can use it for a lot of different things, but the thing about it is I have to use my body to position it. The chop saw is a great setup because you can more accurately cut pieces to length. It wanders a little bit because it's going so fast. Compared with a bandsaw, which we have what are called horizontal bandsaws, or you can also find diamond-tipped blades, which look like a circular saw. Any one of those still removes material, slightly different way, abrasive. They're saw blades, so they're flecking that material bit by bit, tooth by tooth, but instead of an abrasive category, they are that saw category. And that saw category allows for an even more precise cut. Not so it's important when you're cutting things to length, but you have a little bit of wiggle room with that, especially in welded joints. When you're talking about it, so it's okay to use something that has a little bit of give to it, but the thing about that is when you're looking more at something that you're trying to cut like an angle for, I built a lot of little tables that have 45-degree angles in the corners. That doesn't cut that well. So if I'm cutting something and I want it precise, either degree or length, chop saws will work. Don't get me wrong, I've had that saw for about 10 years now. It works great, but I am constantly thinking about when I can replace it with a more precise piece of equipment. So, next thing, flame cutting. As I said, plasma cutter, which is something else. It uses an electrical arc. This uses, I'm going to light it in its current configuration. This has a welding tip on it. It would be for heating or welding. So this is an oxyacetylene torch. I have a fuel, which is acetylene. I have an oxidizer, which is oxygen, pure oxygen. I don't know if you can see them here. My tanks are back by that wall. I don't think you can. It's okay. But they're back by that wall, fairly well secured, so something bad doesn't happen to them. So the cool thing about oxyacetylene is you have this fuel, which is acetylene, which is a gas, essentially. It's actually a gas dissolved in acetone, and you can see it's a hydrocarbon gas. The majority of that, this is all carbon, and for about the next 3 minutes, there's going to be carbon falling over the shop, and when I bring my computer back up to my office, I'm going to wonder why it's black. But that's neither here nor there. So this tip is for welding, and I'll go through, I think I've talked about this previously. So this tip, oops, I'm going to turn that off for a second. It's time to shift my glasses. The reason I shift my glasses here, these are awesome. They look super dorky, but they are great because I can just flip these down. I've mentioned this in previous videos. Shade 5 glasses are really important. I don't know if you can see this, but I've got all the carbon that I just lit off floating around my shop. Shade 5 for oxyacetylene torches, 10 and above for welding when you're using an arc welder. This guy, the reason we want a shade 5 is because this gives off a lot of light. And it's not quite as bright as the arc, but over time you're going to get a spot in your eyesight, and it can be detrimental. So we always want to wear our proper equipment. Okay, so this guy down, back on, and then we've got 3 types of flame. We've got a couple different types of flames. This is pure acetylene. Okay, we bring on the oxygen. So we have mainly an acetylene flame with a little bit of oxygen. That, oops, turn that down just a little bit. There we go. Okay, there we go. So this is called a carburizing flame. You might not be able to see this real great, but basically I have a feather of a feather flame developed in the center of that flame. That came out really dumb, but sorry. Anyway, if I turn it on a little bit more, I end up, let's see, can I get it? No. So right in between those two, right about there, I would call that neutral-ish. I'm not going to really try to get a full neutral flame. And then the next one, this is an oxidizing flame. So neutral will be even, oxidizing, heavier on the oxygen, less acetylene. This would be for welding. I'm going to turn that off. The carburizing flame is what we use for what we call leading. So you probably have heard of body filler. or Bondo. Years and years ago, and before plasticized fillers, we ended up using lead or a lead derivative to smooth out car panels, and it was a really cool process. I've done it in the past, but it's one of those things where it's an older skill that's really fallen out of use. One, it's a little bit dangerous because, lead. The other reason is it takes time and skill. So what I'm putting on here is a cutting head. This turns my welding torch into a cutting torch. I'm going to spin that around a little bit. So still have oxygen acetylene. That main body stays the same. I was able to close them off. I have an additional oxygen control right here, so I'm going to shut that off. I turn my oxygen all the way on the handle. The additional thing that this has is so I can heat the metal up to where it's molten, and then I press this trigger back here. You see this guy right here? I don't know if you can hear it, but I'm basically adding a little bit of oxygen to the process. And by virtue of doing that, I'm going to kick the metal that I am trying to cut out of the way. I still end up with a kerf width on this. It is a kerf. It's hard to control sometimes, other times it's not. There are automatic cutting procedures using torches. You don't see them quite as much, especially since technology for plasma cutters has become more cheap or more inexpensive. It's not cheap, but the quality of those, and then water jet, which is using an abrasive in water at high pressure to cut things. So, light my torch the same way, goggles down, flame. Instead of down here, this is already on. You can see my flame isn't changing. And right here, carburizing, neutral. And then I get into my oxidizing flame. I'm still going up to welding temperatures. So what I do here is I come to the edge, and by virtue of, I wait for it to look cherry red, and then I start moving. And what's happening here, I do need to update my torch a little bit. Oops, hopefully that doesn't damage my computer. I just cut out a little notch there. So I'm going to turn this off. I get rid of my oxygen first, then I get rid of my acetylene. What it allows to do is make sure I don't end up with acetylene someplace that I don't want it. So I cut that little piece out. As I said, I hope I didn't just damage my computer. It's not a super clean cut in this case. My torch isn't necessarily the best, but you can see where I cut it out. I really wasn't, I didn't have a destination on that, but you can see how quick that happened. These are used a lot in the field for metal demo, and what I mean by that is like when ships, the Navy retires a ship, they decommission it, they gut out a lot of stuff, they'll scrap it. That's one of the places you'll see that. You also see it on job sites where you have longer pieces of metal that need to be shorter rapidly, and then you can refine them further, either with a chop saw, bandsaw, horizontal or vertical, I said chop saw. All right, so thinner metal. I've got a bunch of different hand shears. This guy right here, you should be able to see, yeah, you can see in one of my cameras. This is called a Beverly shear. This is a throatless shear. What that means is I can push something in here and keep going. With a lot of hand shears, actually let me grab a set. I don't know why this happens. These are supposedly a left-handed set of shears. I don't know if I'm misunderstanding it, and I have for 20 years, or if it's just left direction. Who knows at this point. I just use the red gripped ones, which, as I said, normally mean left or left-handed. I think it's because I normally cut this way. If you're cutting this way, I don't know at this point. And I'll admit it. And if somebody sees this, out in the YouTubes. Please, somebody correct me, because I'm not sure. And I kind of want to know, or I could look up in one of the books I have. But anyway, so this is one of those things. I can cut this corner off here, and I welded this for something else, I think during one of the other demos. If I tried to cut across it with these, I would run into my hand. There are ones that are offset farther down, but what happens is you start twisting the metal a lot. This does twist it, but this guy right here, what's cool about it, as I said, is it's a throatless shear, and I actually have a lot of control. Also needs some oil. I have a lot of control over it, and I can keep going. See how quick that went? I think you should be able to. Yeah, just checking the cameras, which one. Okay, so that allows me to cut pretty rapidly and pretty cleanly. I can also cut some pretty crazy outside irregular shapes. It's a little bit harder if I were to take this and try to cut in like that, it's a little bit harder. But outside, like arcs and circles that are outward facing, those work pretty well overall. Okay, what time we got? 2:23. So I normally try to keep these between 20 and 30 minutes. I might have moved a little bit fast through that stuff, but so long story short, cutting metal is a process that you can use many different things. You can use cut-off wheels, sawzalls, chop saws. The other thing, we didn't get into a lot of the other things because I don't have them. They're expensive tools. But the purpose of this one was to kind of demonstrate that different metals and different ways of cutting metal. So next week, I'm going to do a blacksmithing demo. So you'll get to see the rest of my shop, which is what exists behind the camera. The camera actually lives in my blacksmithing area, which is, it's kind of a hodgepodge of things I've put together and built. And it's neat. It's one of those things where it's far from complete, it's far from done, but I'll share it with you next week. So stay safe, be healthy, and there's a spider in front of my face right here. Okay, see you later.